Hi all, in this video I am going to explain most important MCQs in our electronics. Problem number 1. In figure A, capacitor is charged to V0 equal to 50 volt with upper plate positive. Switch S is closed at T is equal to 0. Current through the circuit at T is equal to 0 and final voltage across C are respectively. The condition given is the switch is closed at T is equal to 0. The switch is closed at T is equal to 0. So next I am going to apply Kirchhoff's voltage law around the closed loop and write the equation. When the switch is closed, anode of the diode is connected to the positive potential and cathode is connected to the negative potential so that it is in the forward bias condition. So diode starts conducting. Now I am going to write the voltage equation for this closed circuit. You have to apply KVL. So it is the equation R into I of t plus 1 by C into integral I of t dt. That is equal to, instead of 200, I have to take as Vs. I am going to apply the Laplace transformation with all initial condition. The equation is R I of S plus 1 by 3 into I of S by S minus of minus, both are opposing, this direction of current and this current, and see the voltage, both are opposing with each other, so that is minus Q0 by S. So Q0 by S, that is equal to Vs divided. What is Q? Q is equal to C into V. So R into I of S plus 1 by C into I of S by S plus C into V0 divided by S, that is equal to Vs by S. Next, what I have to do, I am going to expand this equation. So I of S plus I of S divided by ds plus Cc get cancelled. So V0 by S, that is equal to Vs by S. Take Is, I of S now. So R plus 1 by Cs, that is equal to Vs minus V0 divided I of S into RCS plus 1 divided by Cs equal to Vs minus V0 divided by S. Both the S get cancelled. Now I have to cross multiply this. I of S into 1 plus RCS equal to C into Vs minus V0. Next, I of S equal to C into Vs minus V0 divided by 1 plus RCS. Then I of S equal to C into Vs minus V0. Take RC outside. S plus 1 by RC. CC get cancelled. Finally, I get the answer. Vs minus V0 by R into 1 divided by S plus 1 by RC. Next, I have to apply the inverse Laplace transformation to find out I of t. Inverse Laplace to find out I of t. So I of t is equal to, let's write the constant Vs minus V0 divided by R into 1 by S plus 1 by RC. What is 1 by S plus A? 1 by S plus A is e power minus at. The similar manner, e power minus t by RC. So this is the equation of I of t. And next I am going to find out final voltage across C. So what is the voltage across C? That is V is equal to two voltages. One is by I of t current, and next already one initial charge is there, V0. So 1 by C into integral I dt plus V0. So 1 by C into, what is I? That is Vs minus V0 by R into integral 0 to t e power minus t by RC plus V0. 1 by RC into Vs minus V0 into e power minus t by RC divided by minus 1 by RC. So this RC are get cancelled. So Vs minus V0 into minus of, first apply the upper limit e power minus t by RC. Let's write the lower limit. The answer is Vs minus V0 into 1 minus e power minus t by RC. Okay, now I am going to find out the current through the circuit at t is equal to 0. So at t is equal to 0, I of 0. I of 0 equal to, put t is equal to 0. E power 0 is 1. Okay, e power 0, that is 1. So what about the value I of 0? I of 0 equal to Vs minus V0 by R. What is Vs? Vs is 200. So V0 is 50 divided by the R value is what? R is 10. So what is the answer? 150 divided by 10. That is equal to 15 ampere. So 15 ampere, A and T also 15. Okay, next find out final voltage across C. So final means that is infinite. Final VC of infinite I am going to find out. VC of infinite equal to what? Vs minus V0 into 1 minus e power minus t by RC. E power minus infinity is 0. So Vs minus V0 is the final answer. So what is Vs? Vs is 200 plus 1 V0 is there, no? V0. Here also in the derivation plus V0. V0 get cancelled, 200 only. So Vc of infinity 200. Vc of infinity is 200 volts. Which one is correct? Option A is the correct answer. Next, we are going to see the problem 2. In figure A, suppose capacitor is charged to plus 50 volt Plus 50 volt means here the direction is negative to positive. That is lower plate positive. Here upper plate no. Here lower plate is positive. Switch S is closed at T is equal to 0. Current through the diode T is equal to 0 and final voltage across C are respectively. Already in the previous problem, I have derived the equation of current I of t. The equation is Vs minus V0 by R. But here only one difference, Vs plus V0 by R. This Vs here, upper plate is negative and lower plate is positive. And both are in the same direction. So put plus V0. 200 plus 50 by 10. 25 ampere. And next, what is the final voltage across? Final voltage across C, when the upper plate is positive or upper plate is negative, both the cases, we get the same answer Vs, that is equal to 200 ampere. Okay, which one is correct? The option B is correct, 25 ampere and 200 volt, not ampere, 200 volt. Next problem, in the circuit of figure A, switch S is closed at T is equal to 0, with IL of 0 equal to 0 and VC of 0 equal to 0. So there is no initial conditions given. In steady state, VC equal to, that is given. So here, for switch is closed, this is a condition. When the switch is closed, diode starts conducting. And what is the equation? L into di by dt plus 1 by c into integral I dt, that is equal to Vs. Apply the Laplace transform. So L into S I of S minus I of 0 plus 1 by c into I of S by S minus U0 divided by S, that is equal to Vs by S. All the initial conditions are 0. Inductor, the initial condition is 0. Capacitor also 0. So put 0 here. Here also have to put 0. So what is the equation? L into S into I of S plus 1 by Cs into I of S, that is equal to Vs by S. Now have to cross multiply this. So LC square plus 1 into I of S divided by Cs, that is equal to Vs by S. S is cancelled. What is I of S? I of S is C into Vs divided by LC square plus 1. Next, I of S is CVS, have to take LC. So 1 square plus 1 by LC. CC get cancelled. So VC by L in the S square plus 1 by LC. What is omega naught? 1 by square root of LC. So next step is VC by L into S1 by S square plus omega naught square. I am going to apply the inverse Laplace transform. Before applying the inverse Laplace transform, first of all, see the second part of the equation. This is somewhat look like the Laplace transformation of sine omega t. So only one term missing. In the numerator, omega is missing. So what I have to do, I am going to multiply both numerator and denominator by omega naught. Okay, next I have to substitute the value of omega naught. So VC divided by L into square root of 1 by LC into omega naught plus S square plus omega naught square. Okay, here I have to cancel this. So VC into square root of C by L C by L into omega naught divided by S square plus omega naught square. Take inverse Laplace transformation. So VC square root of C by L sin omega naught t. So this is I of t. This is I of t. The question is, in steady state, VC is equal to. So how to find out VC? VC equal to, what is the formula? 1 by C integral I dt. 1 by C integral, what is I? I is VC square root of C by L in this sine omega naught t. And put the limit 0 to t. So 1 by C into VC into square root of C by L into, have to apply the limit and finally I get 1 minus cos omega naught t. In the previous video, the same derivation I have explained in a detailed manner. So I have given that in the description link. So I have here C get cancelled. So 1 by root LC into VC into divided by omega naught. Hereby applying integration 1 minus cos omega naught t divided by omega naught. This missing here into 1 minus cos omega naught t. What is 1 by root LC? That is omega naught. That is numerator. Both omega naught get cancelled. So VC equal to yes, not VC, VS. Yes. VS into 1 minus cos omega naught t. At steady state, in steady state means t is equal to 5. Then only the cycle is completed. This is the current waveform, current cycle. So the last 0 and last value is 5. So you have to put the pi here with 2 into Vs. 1 minus of minus 2, that is 2 Vs. So Vc equal to 2 Vs. Vs given as 100. So the answer is A. Option A is the correct answer. Next problem. In figure A, V1, V2, V3 are zero-centered PMMC voltmeter. In figure A, V1, V2 and V3 are zero-centered PMMC voltmeter. The circuit is initially relaxed. Switch S is closed at t is equal to 0. In steady state, reading of voltmeter V1, V2 and V3 respectively. PMMC voltmeter, which is used to measure the DC values of voltage and current. Okay. See the circuit. The condition number 1 is switch is closed at t is equal to 0. Okay. If the switch is closed at T is equal to 0, the diode anode is connected to positive and cathode is connected to the negative terminal of the battery. So it starts conducting. Now I am going to find out V1, V2, V3 in a steady state. In a steady state, it acts as the inductor, acts as the short circuit. So V2 equal to 0. What about V1 and V2, V3? Already in the previous problem, I got the answer for VC, that is 2 into Vs. So the same equation is used here. The circuit is same. Vs is 100, 200 volts. So option C may be correct, 0 to 100. Again, I am going to find out Vd. How to find out Vd? Here this is Vs. So write the voltage equation by applying KVL. Vs minus Vd minus Vl minus Vc equal to 0. Vd equal to Vs minus Vl minus Vc. What is Vs? Vs equal to 100. What is Vl? Vl equal to 0. And what about Vc? Minus 200. The answer is minus 100 volt. So minus 100 is the correct answer.